As February 2026 arrives, Europe finds itself at the center of a remarkable weather event that's capturing the attention of meteorologists and residents alike. Across the continent, people are bracing for a dramatic shift in weather, with many cities preparing for conditions not seen in years. A widespread cold spell is setting in, stretching from Scandinavia down to the heart of Central Europe, and even reaching parts of the West. Temperatures are dropping well below seasonal averages, especially in northern and central regions, where the mercury is plunging to levels rarely seen this late in winter. This isn't just a typical winter chill. Major atmospheric events high above us are driving this change, creating a unique and challenging situation for millions. Instead of the usual milder Atlantic winds that often bring rain and slightly warmer air, cold air from the north and east is sweeping in with force, bringing crisp, clear days for some, but for many others, it means heavy snow, icy roads, and hazardous travel conditions. Meanwhile, southern Europe isn't escaping unscathed. Persistent low-pressure systems are causing heavy rain, flash flooding, and widespread disruption in cities from Spain to Greece. The root cause? A major stratospheric warming event has disrupted the usual Arctic circulation, sending cold air cascading down into Europe and breaking up the polar vortex. Meteorologists are closely monitoring how severe and long-lasting this cold period will be, using advanced models to predict what might come next. It's a classic winter pattern, but with a dramatic twist. So stay updated, as conditions could change quickly and unexpectedly, impacting daily life and travel plans. Prepare for colder temperatures, possible travel disruption, and significant snowfall, especially in the north, where transportation and infrastructure could be put to the test. This marks a striking finale to the winter of 2025-2026, reminding us how interconnected our weather systems truly are, and how quickly nature can surprise us all. The main driver of this intense cold snap is the polar vortex, a vast, spinning pool of frigid air that sits high above the North Pole, encircling the Arctic like a frozen crown. This swirling mass of cold is a regular feature of our planet's upper atmosphere, and it plays a crucial role in shaping winter weather across the northern hemisphere. Under normal conditions, a strong and stable polar vortex acts like a barrier, keeping the coldest air locked up far to the north. But this February, something unusual happened. A phenomenon called sudden stratospheric warming rapidly heated the upper atmosphere, dramatically weakening the vortex's grip. When the vortex wobbles, splits, or becomes unstable, it can no longer contain the Arctic chill. This allows huge masses of icy air to spill southward, plunging Europe, North America, and Asia into deep freezes and bringing extreme winter weather to millions. Adding to the drama, a high-pressure system known as the Greenland block is now in place. This powerful atmospheric roadblock is diverting the jet stream, forcing it to dip south and opening a direct pathway for freezing Arctic and Siberian air to surge into Europe. The result? A sustained period of colder-than-average temperatures, with biting winds and heavy snowfall blanketing cities and countryside alike. This setup is why so many are reaching for extra layers and bracing for a winter that feels especially harsh. It's a vivid, real-world example of how dramatic events miles above Earth's surface can ripple down and shape the weather we experience every day, reminding us that our atmosphere is a complex, interconnected system. The stability of the polar vortex is absolutely crucial. When it's strong and undisturbed, winters tend to be milder. But when it's disrupted, Europe's winters can quickly turn colder, snowier, and far more severe than usual. This year's dramatic shift is a powerful reminder of the delicate balance in our atmosphere, and how even small changes high above can have dramatic consequences for life on the ground. Interestingly, a weaker version of the polar vortex exists during the summer months as well, but because temperature contrasts are much smaller, its impact is far less noticeable, and Europe enjoys calmer, milder weather. So, the next time you feel that icy wind biting at your face, remember, it started high above, in the swirling chaos over the pole, and traveled thousands of miles to shape the winter you're experiencing right now. As these weather events unfold, meteorologists have a new tool, the MTGS satellite, launched by the European Space Agency in January 2026. Orbiting 36,000 kilometers above Earth, MTGS is Europe's first hyperspectral sounder, offering a continuous, detailed view of the atmosphere. With 1700 infrared channels, it creates 3D maps of temperature and humidity, revealing the structure of the air, not just the clouds. This technology allows forecasters to track temperature, moisture, and wind at different altitudes, improving severe weather predictions. MTGS scans Europe every 30 minutes, providing near real-time data for more accurate forecasts. Working alongside its sister satellite, MTGI, it delivers the most comprehensive weather picture Europe has ever had. Fun fact: to stay fixed over one spot, MTGS travels over 11,000 km/h, perfectly matching Earth's rotation. The first images from MTGS have already showcased its power, capturing detailed views of global weather and even tracking volcanic ash plumes in real time. Its 3D atmospheric scans enable nowcasting, spotting the early signs of storms or downpours before they appear on radar. This means more precise, timely warnings for flash floods, hail, and strong winds. MTGS also monitors air quality, measuring pollutants like nitrogen dioxide and ozone across Europe. The sheer volume of data is staggering. One day's output would fill thousands of DVDs. Processing this information quickly is vital for public safety and health. With MTGS, Europe is entering a new era of weather prediction. While the polar vortex shapes our winter, another global player is changing. La Niña is rapidly fading. For years, cooler Pacific waters influenced weather worldwide, including Europe. Now, a surge of westerly winds is warming the Pacific, ending La Niña faster than expected. We're entering a neutral phase, with ocean temperatures near average, a major shift in the climate system. This transition brings unpredictable, volatile weather as global patterns adjust. Fun fact: La Niña means the little girl in Spanish, named as the counterpart to El Niño. As La Niña fades, El Niño is set to emerge by summer 2026, peaking next winter. El Niño warms the tropical Pacific, releasing heat and moisture that ripple through global weather systems. In Europe, El Niño often nudges the jet stream and storm tracks, sometimes favoring high-pressure blocks that let cold air in from the north and east. This increases the chance of a colder-than-average winter for northern Europe in 2026 to 27. Still, El Niño is just one factor. Other elements like the polar vortex and Atlantic temperatures also play a role. Historically, rapid shifts from La Niña to El Niño have led to colder winters in Europe. The name El Niño comes from Peruvian fishermen, who noticed warm Pacific waters around Christmas, hence the Christ child. To improve forecasts, meteorologists are turning to artificial intelligence. Traditional models use physics and supercomputers, but AI learns from decades of weather data, spotting patterns and relationships. In 2025, the US National Hurricane Center used AI to outperform some traditional methods. AI excels at processing the massive data streams from satellites like MTGS, identifying subtle signs of severe weather. This boosts nowcasting accuracy and speeds up warnings. AI isn't replacing traditional models, but enhancing them, combining physics with pattern recognition for better forecasts. The European model, already world-class, is getting even sharper with AI integration. Fun fact: some AI models can generate a 10-day forecast in minutes on a standard computer. Despite advanced satellites and AI, human meteorologists remain essential. Models provide guidance, but it's the forecaster's expertise that interprets, corrects, and communicates the data. Local knowledge helps refine predictions, knowing how geography affects snow or rain, for example. During major storms, this human touch can mean earlier, more accurate warnings. Professional forecasts blend model output with expert judgment, making them more reliable than basic weather apps. The future is a partnership. AI and supercomputers handle data, while humans provide context and critical thinking. Fun fact: human forecasters can improve model accuracy by up to 25% by correcting known biases. So, what's ahead for Europe's weather? As we look toward the coming months, northern and central Europe should brace for a cold, unsettled end to winter. Temperatures are expected to remain below average, and conditions could be harsher than usual, especially in areas already dealing with snow and ice. The recent disruption of the polar vortex is bringing more frequent frosts, heavier snowfall, and travel disruptions across much of the continent. Meanwhile, southern Europe isn't off the hook. Persistent low-pressure systems are set to bring heavy rain, flooding risks, and even the chance of strong winds in some regions. As spring approaches, the atmosphere will be in a state of transition. Expect unpredictable swings in temperature and weather patterns as La Niña gradually fades and El Niño begins to build. This means we could see sudden warm spells followed by chilly snaps and rapid changes in rainfall and sunshine. Fortunately, the new MTGS satellite and advanced AI-powered weather models are giving meteorologists unprecedented insight. These tools help forecasters track fast-moving systems and provide more accurate, timely warnings for communities across Europe. Looking further ahead to winter 2026-27, the development of El Niño suggests a higher probability of another cold and potentially snowy season for northern and western Europe. This could mean more frequent cold snaps and a greater risk of prolonged wintry conditions. Of course, nothing is certain. Long-range forecasts always come with some uncertainty. But El Niño's influence is a key factor shaping the outlook, and it's something meteorologists will be watching closely in the months ahead. Thanks to cutting-edge technology, expert meteorologists, and international collaboration, we're better equipped than ever before to understand, predict, and prepare for whatever the weather brings next. And remember, even with all our advances, the butterfly effect reminds us that weather will always keep us guessing. Stay tuned, stay prepared, and expect the unexpected.